Hi folks, we're going to take a look at number 15 from page 180. So here they're giving us a quartic polynomial that's missing some coefficients, and they want us to find these four missing coefficients given some information about the function. Okay, so first of all, since we're looking for four unknowns, we need four pieces of information, and we're actually given four pieces of information, because if there's horizontal tangents at these points, it means these points are on the curve. Okay, but horizontal tangents also mean that the derivative is equal to 0. So that means that the derivative -2 and the derivative at 0 are both equal to 0. Okay, so those are four pieces of information. So again, in terms of where to start and where to go, usually anything that involves a 0 is a good place to start. So I notice here that I've got x equals 0 gives an output of -9. In fact, that's just the y-intercept. Okay, so here when I plug in f at 0, I just get -9. But of course, when I actually plug in 0, these four terms all disappear. So I'm just left with d. And so d is equal to -9. So that was a nice, easy one we were able to determine. Okay. Now, instead of plugging in this -72, actually I just looked in the book, this should be -73. Okay. Before plugging in this point, which is some ugly numbers here, I think I'm going to go to the derivative. Since I know the derivative is going to be equal to 0, it might be something easier to work with. Okay, so let's find the derivative of this function. So here we have 3 times derivative of x to the fourth, so 3 times 4x cubed, which gives us 12x cubed, plus derivative of x cubed is 3x squared, so we have 3ax squared, since a is just a constant. Okay, similarly here we have 2bx, then we have the derivative of x is just 1, so I'm just left with c. And of course the derivative of d, or -9, is just equal to 0 since it's a constant. Okay, so here's my derivative, and I know that at 0, the derivative needs to be equal to 0. So that's a good one to start with. I know that f prime at 0 needs to be equal to 0 since there's a horizontal tangent there. But again, when I stick in x equals 0 into this equation, or this expression, the only thing I'm left with is the c. So c is equal to 0. And there you go, we found our second value. Okay, so I'm going to keep going with the derivative here, and I'll now use the fact that at -2 we have a horizontal tangent. So that means that f prime at -2 needs to also be equal to 0. Okay, so let's stick -2 into the expression here. So we have -2 cubed is -8 times 12, so that's -96. -2 squared is 4 times 3, so plus 12a. Here we've got -2 times 2 is 4, so minus 4b. Okay, and we don't need the c since we already determined that it's equal to 0, so that's equal to 0 here, since we have our horizontal tangent. So what we have is a first equation with a and b. 12a minus 4b is equal to 96. And we can actually simplify this equation, divide both sides by 4. So 3a minus b is equal to 2, 16, 4, 24. Okay, so there's our first equation involving just a and b, my two remaining unknowns. Okay, so now I'm going to take this point, -2, -73, and input it into my function, and I'll get another equation with f and b, with a and b. So I know that f at -2 is equal to -73. So let's stick in -2. So we've got -2 to the 4 would be 16 times 3. So that's 48. Okay, plus -2 cubed is -8. So actually that'll be minus 8a. Okay, -2 squared is 4, so plus 4b. Okay, c was equal to 0, so that's not there anymore, and plus d, so d is -9, so -9, and all of that is equal to -73. Okay, so let's simplify this here. We've got -8a plus 4b, and I think I'm going to use a calculator for this here. Don't want to make a mistake. So -73. So we're going to subtract the 48, and we're going to add the 9. Okay, so here we have -112. Okay, and let's see if -112 is divisible by 4. Simplify the equation. Yeah, that's good. So divide both sides by 4. So we've got negative 2a plus b is equal to negative 28. Okay, and there's our second equation. Okay, so now I'll bring this over here so I can do a quick elimination. So 3a minus b equals 24. And here we're going to add the two equations in order to eliminate the b's. So negative 2 plus 3 is just 1. So a is equal to negative 28 plus 24 is negative 4. And so there we have it. So again, a lot of algebra here, but it's all stuff, we know how to do. Okay, so I'll use equation 2 to solve for b here. So we've got negative 2 times a, which is we just found was negative 4, plus b equals negative 28. So b is equal to negative 28. So this is positive 8. So when I bring it to the side, minus 8. So negative 28 minus 8 is negative 36. And there we go. So that means, let's put everything together, that means that my function is actually 3 times x to the 4. Okay, and it was plus ax cubed. So since a is negative 4, minus 4x cubed, plus bx squared. So that's going to be minus 36x squared, plus cx, but c was just equal to 0, so that disappears. And then plus d is minus 9. So there we go. There's our equation. Okay, so those are the 4 values. And now there's a second question. It says that there's a third point that has a horizontal tangent. Find this point. Okay, so I'm actually now going to have to go back and work with the derivative again. Okay, so for, I guess this is b here. Find the derivative again. I could stick my numbers back into here, but it's just so easy to find this derivative. I think I'll just do it directly. So here we have 12x cubed minus 12x squared minus 72x and minus 0. So there's my equation, and apparently there's a third point where the derivative is going to be equal to 0. So let's solve for that. Here we've got 12x as a common factor, so we're left with x squared minus x, and this is going to be minus 6. Okay, and we solve that, or factor it. We have x minus 3, x plus 2. Okay, so we already know that x equals 0 gives us a horizontal tangent, that x equals negative 2 gives us a horizontal tangent. So the other one we were missing was x equals 3. Okay, but since they're asking us for the point at which there's a horizontal tangent, I'll have to stick this into the equation. So we have f at 3 is equal to, and again, I think I'll put this into the calculator just to be sure. Okay, so we have 3 to the 4th is 81 times 3, minus 4 times 3 cubed is 27, minus 36 times 3 squared is 9, and then minus 9. Whoops, I think I forgot something there. 36 times 3 squared, 9, and then minus 9. Okay, negative 198. Okay, so for our answer for B is 3, negative 198. Okay, and there's a last part to the question. It says, for these 3 points, determine which one corresponds to a local max, min, or neither. Okay, so again, we're going to be working with the derivative here. Okay, but since we already have it in factored form, all the work is done for us. So it's just a matter of testing the derivative, the sign of the derivative in these 4 intervals. So here we have negative 2, 0, and 3. And again, there's no need to actually plug numbers into the derivative, since this is just a cubic with a positive leading coefficient. We know that it behaves like this, so it goes from negative to positive to negative to positive. And so at negative 2, the functions, remember this gives us the increasing and decreasing behavior, so it goes from decreasing to increasing. So we have a min here. Okay, at 0, it's going from increasing to decreasing, so we have a max. And then again at 3, we're going from decreasing to increasing, so we again have a min. Okay, and that's it for this one. So pretty long problem, lots of algebra to do. Okay, but just to do a quick recap, number one, use the pieces of information you have to determine the missing unknowns, and then from there use the information that you know how to in terms of factoring to find zeros of the derivative and finding the sign of the derivative to determine local maxes and mins. Okay, that's it for this one.